Last but not least, let's see how we can use Mathematica to automate the process we saw in the previous video for us, creating a random shuffling of our values within the matrix, updating the adjacency matrix accordingly, and computing our Hamiltonian cycles. So what we're going to do is use a random function to reorder the numbers of interest to us, and we're going to save that as this permutation that we called P1. Next, what we're going to do is create our new adjacency matrix that I've called perm matrix here, which takes our original matrix and shuffles the rows and columns according to this random permutation. If I take off the semicolon, we can see what happens when we do that. We also need to update our adjacency graph according to this new matrix, just so that Mathematica has a new graph name to pass to our find Hamiltonian path function. So let's update the graph as well. And last but not least, enter find Hamiltonian path. You can see now that we have a different labeling of those 9 vertices. What we want to be a little bit careful of is that this is telling us that 6, 8, and 5 should be a district, 7, 2, and 9 should be a district, and 3, 1, and 4 should be a district. However, if we go back to Excel, you'll notice that 3, 1, and 4 are not connected in my original numbering scheme. So what we have has been pretty quick and easy, but it's a little bit lost because 3, 1, and 4 is not contiguous. It is contiguous, however, in the numbering scheme in which we've rearranged things. And you can see that if you ask to view that graph, G1, and you add your vertex labels. You'll see that 3, 1, and 4 are connected, but they're not connected in my original numbering scheme. So that's a technicality, but there is an easy fix for us in Mathematica. What we need to do is understand the original shuffling. Our original shuffling sent the 1 to the 4 spot, and the 2 to the 5 spot, and the 3 to the 7 spot, and so on. And so what we want to do is kind of list what this Hamiltonian path is, but instead of listing it according to the new vertex labels, we'd like it to list this Hamiltonian path with the numbering scheme of our original vertex labels. In order to do that, we just need to take this list and unshuffle the permutation that we did originally. And Mathematica has a nice command for replacing things according to a key, which is right here, permutation replace. So what we need to do is we need to take a list where we want to make replacements, and then we need to tell as the second parameter what replacements to make. Now P1 is the list of replacements to make, but the list where we want to do that type of replacing was the output of our find Hamiltonian path function, which took place here at input 102. So let's go down here, and instead of 125, let's type in 102 and make that replacement. And we now have the Hamiltonian path in our original graph, 963, 258, 741. We return to Excel and look at our numbering scheme, 963, 258, and 147. Voila, we've got a different collection of districts from that find Hamiltonian path function in Mathematica. So what you'll be doing this week is, for one, moving away from the 3x3 example to the 10x10 example that we really want to study, and we'll just be automating the process that we've shown in these videos to do this many times and to also keep track of how many of one political party wins the districts once we know them in order to get a feel for this gerrymandering measure.